All right, so example 6, which is the last example in Polygon. I hope that, so there are the two topics that we would have covered on the geometry um, would have covered angle properties and polygons. And now we're getting ready now to start Pythagoras theorem and the trig ratio. Also remember that for trig ratio, you are going to need a scientific calculator. Example 6, it says in the diagram below is a regular polygon with center O. All right, so this is a regular, I think it's a hexagon, because if it has 6 sides, it's a hexagon. A regular polygon with center O and PQ or QP is equal to 6 centimeters. We're to calculate to one decimal place, A, the size of angle POQ, which is this angle here. And we're going to do it the same way which we did the one before, using the fact that the radii divides the polygon into identical isosceles triangles, that all of these angles are the same. All of these angles are the same. All right, so if all those angles are the same, it means that 6 theta, because it's 6 of them, would be equal to 360 degrees. And there are what? Angles at a point. So if we add up the 6 angles, we'll get 360 degrees because they're angles at a point. The shortcut for adding theta 6 times is to simply multiply theta by 6. If I divide both sides by 6, I'm going to get theta, which is angle POQ, is equal to 60 degrees. Now, if you all remember that all of these were isosceles triangles, it means that if this is 60, it means that these two here and here must add up to 120. Do you agree? Help me now?
Yes, sir.
Because it's an isosceles triangle, and the base angles of an isosceles triangle are equal.
Equal.
So these two must add up to 120. So 2 alpha is equal to 120. If you divide that by 2, you're going to get alpha is equal to 60 degrees. So what I wanted to show is that all of the angles are what? 60 degrees. Help me now?
Yes, sir.
All the three angles inside are 60 degrees. Therefore, you see each of the triangles, in this instance, the triangles are not isosceles. They would be equilateral. So it means that if this is 6, this is also 6, and this is also 6. So all I'm saying is that when your polygon is a regular hexagon, the radii doesn't divide the polygon into just isosceles, it divides it into equilateral triangles. So if this is 6, it means all 3 sides are 6. All right?
Sir, scaling too?
Yeah? No scaling.
Scaling.
No scaling. It's isosceles because it's an equilateral triangle. So we just work this out to be 60. And we show that if that is 60, this is 60, and this is 60. Therefore, you see this triangle, it's what you call an equilateral triangle. If all 3 angles in a triangle measure 60 degrees, that triangle is an equilateral triangle, which is a special type of isosceles triangle. So all the sides are 6 centimeters. The equilateral triangle is the regular triangle. So all the sides measure 6 centimeters. 6 centimeters. So the area of triangle POQ, the area would be equal to a half AB sine C. It would be a half times 6 times 6, the sine of 60 degrees. 3 times 6 is 18 sine 60 degrees. If you put that in a calculator,
So you word the total again, the same parts.
you have to put it in. You're going to have to press any calculator, press 18, 1/8, then press sine. You should see a button marked sine on the calculator.
We get 15.6. So.
All right, so the person who asked that question, you understand what I'm saying now? You have to press 1/8 first, then sine, then press 60 degrees, then press 60, then press equal. And the answer here is 15.6. And this is centimeters square. The unit of area is always what? Square. All right, now the area of the entire polygon. The area of polygon would be equal to 6 times 15.6. And this would be equal to
93.6 centimeters square.
93.6 centimeters square. All right, so get ready for Pythagoras theorem and the trig ratio.